we are going to go over some questions of this homework 2.7 WSM2. And on this one, we're graphing parabolas. Yeah, numbers 1 and 2 have the a value of 1. Number 3 has a value of -1. But number 4, you're going to have to modify your pattern according to that new a value of 2. Number 6, you also have to modify it. Number 5, you also have to modify it. But we already gave a whole lesson on that. You guys should be good with that. Let's turn to the back side. Let's talk about transformations. Yeah, I apologize. On the back side, we don't have the answers. We have a little set of notes on transformations, and we also have examples and a little bit of homework on describing transformations from the parent graph to the original graph. So let me do this. Recording. Okay, so listen up, guys. If your a value is 1, we know we have the regular parabola, correct? Okay, with the pattern 1, 1, 2, 4, 3, 9. What if instead of y equals x squared, instead of the a value being 1, what if the a value were -1? It would be opening down, right? Now, we're going to use the correct vocab word for math that says opening is going to be a reflection over the x-axis. So instead of saying it opens down, we're going to say it gets reflected over the x-axis, right? If the a value is 1, it doesn't mean it's wider or narrower. It's still the same pattern, 1, 1, 2, 4, 3, 9. Everybody understand that? Yeah. Okay. What if here's your regular a value of 1. What if your a value becomes 1/2? What happens to the parabola? It gets wider, right? What if it became 1/5? It gets even wider. What if it became 1/10? It's so wide it almost looks like a line, but it's still really wide, right? So the a value, the closer it gets to 0, the wider it gets. Now, we understand the word wider, but in mathematics, the vocab word that we want to use for getting wider, it's called a vertical compression. When you compress something, you smash it, right? So vertical means up and down. When you compress it, it gets wider. So keep that in mind. A vertical compression really means that it's getting wider, okay? And how does it get wider? If your a value is closer to 0. Like 1/2, it gets compressed. 1/4, it gets more compressed. 1/10, it gets really compressed, right? Okay. How about if here's your regular a value of 1, y equals x squared. What if it became y equals 3x squared? What would happen to my parent graph? It gets narrower, right? Now, we all understand that if you go from the a value of 1, y equals x squared, to the a value of 3, y equals 3x squared, it gets narrower. Now, in math, we could use the word narrower, but what does it really mean? It means that it gets vertically stretched, okay? Vertically stretched, vertically compressed. Instead of wider, we're going to say vertically compressed. Instead of narrower, we're going to say it gets vertically stretched. Does that make sense? Yeah. Yes? Okay. Pause that. So let's go to our notes here, and we want to describe transformations from the original parent graph to the graph or the function that they give us, all right? And in order to describe transformations from the original parent graph to the new graph, we must go through each of these possibilities in this order. Okay, so the very first thing to ask yourself is, does it get reflected over the x-axis? Obviously, if your a is negative, then it does get reflected over the x-axis. If your a is positive, you don't have to worry about stating about anything being reflected because it's going to open up, right? And then you move on to this next part. In addition to telling you whether it opens up or down, the a value also tells you if it's wider or narrower. Okay, so the thought process here, the second thing to do is ask yourself, does it get vertically stretched or compressed? And by what factor? Now, you guys are probably thinking, what the factor, right? We don't know. Yeah. Okay, it wasn't that funny, right? Okay, maybe it was. Hey, what the factor, yo? No, okay. All right, sorry. Back to the notes. By what factor does it get stretched or compressed? Obviously by the a. The a is the factor that it gets stretched or compressed by. Okay, so if the a value is closer to 0, we know that it gets wider, right? If it's a fraction less than 1, it's going to get wider. That's what we call a vertical compression. And I put in parentheses, it gets wide, right? But if the a value is further away from 0, which means that it's greater than 1, right? Then it's going to be a vertical stretch. So instead of narrower, we're going to say vertical stretch. And you know what? I didn't state that. So let's all go to these notes right here. And let's put in parentheses right here, a vertical stretch means what? Narrower. Narrower, or just narrow, whatever. You need to know a vertical stretch means that it gets narrower, and you need to know that a vertical compression, it gets wider. Okay? And the final thing to ask yourself is, does it move left, right, up, or down? And that's all according to H and K. Always state your left-right shift first, which is according to H, and then state your K shift next. Oh, sorry. Your K shift, not the other word. The K shift is up and down. All right. So up here we have an example. Check this out. This is what the type of question you're going to be asked on the homework and very likely on the test this Friday. It says, describe the transformation from f of x to g of x, where f of x is your parent function, the regular parabola x squared, to your new g of x function, which is -2 instead of the a value of 1, it's -2, with the h shift and with the k shift, right? So we need to describe it. So we're going to go through this thought process right here. Number one, does it get reflected over the x-axis? Yes, it does. So that's the first transformation that we write down. It gets reflected over the x-axis. How do we know that? Because the a value is negative. Okay. And then after that, you got to ask yourself, what else does the a value tell you? Does this get wider or narrower? It gets narrower. Remember, the closer it gets to 0, that's the one that gets wider. The further away it is from 0, it gets more narrow. But of course, the appropriate words for getting narrower is that it's a vertical stretch. It gets vertically stretched by a factor of 2. It gets vertically stretched by a factor of 2. And finally, at the very end, talk about your shifts, left or right, up or down. So right here, the h value is 4, which means it gets shifted 4 units to the right, think opposite, and 6 units down, take k for what it is. So these are all the different phrases that you need to state, that you need to describe when you're trying to describe the transformation from your original parent graph, y equals x squared, to this new parent graph right here. It's a lot of stuff to know, but hopefully after graphing, you're already comfortable with how a affects your graph and how the h and k affect your graph. Let's take a look at example 2. Describe the transformation from f of x to g of x, where f of x is the parent graph, y equals x squared, and g of x is 1/4 parentheses x plus 1 squared, no k. So let me ask you this. Does, from the original to this one, does it get reflected over the x-axis? No, the a value is not negative, so you don't state anything about a reflection, right? It still opens up. What else does the a value tell you? It's a value of 1/4. What does it tell you about your new parabola? Is it going to be wider than the parent graph or narrower than the parent graph? Wider. Now, what are the words that we use for wider? Vertically compressed, right? Vertically compressed means wider, okay? Compressed, it gets wider by a factor of 1/4. Okay, so if you're like, it gets vertically compressed, by what? Well, how does it get compressed? Well, because of the 1/4. So you say by 1/4. Okay, and then at the very end, it gets shifted only 1 unit to the left because you think opposite on H. You guys get it? And that's the mini lesson on transformations. And that should be really easy now because of the fact that we've been graphing so many parabolas, right? So number one's cake. Does it get vertically, let me start with the correct thing to do. Does it get reflected over the x-axis? No. Doesn't get reflected over the x-axis. It opens up because a value is 1. Does it get vertically stretched or compressed, or is it just a regular parent graph a value? Regular parent. So I don't have to state anything. The only type of transformation from the parent graph to this one is a shift. And what kind of shift is it?
2 units.
2 units to the? So shifts 2 units to the left. Ta-da! Why left? Why left? Because the h value, you have to think opposite. That really, the h value is really -2. Guys, pay attention. All right, so let's go to something more challenging. Let's say, I don't know, let's do number 4. So, does this one get reflected over the x-axis?
Yes.
In other words, does it open up or down? It opens up, so it does not get reflected, right? Okay, so we're not going to mention that it gets reflected because it doesn't get reflected. Does it get wider or narrower?
Narrower.
Narrower, because the a value is further away from 0 than your parent graph. So it's definitely going to get narrower. How do we describe that transformation that it first gets narrower? You're going to say it gets vertically stretched. Now you could put in parentheses, what does vertically stretched mean? It means narrower. It gets vertically stretched, but let's finish out the phrase by a factor of, what's the factor that we're stretching it by? 2. Obviously, if this were a 3, you'd be stretching it by 3. If it were a 5, you'd be stretching it by a factor of 5. It's that simple. Okay, so that was first dealing with the A. It didn't get reflected. I don't mention it. It does get stretched because the A value is 2. Now, what else am I going to state with regards to transformations? The shifts. It gets shifted 4 units to the right. That's right. And what? 6 units down. That is a complete description of your transformation right there. So if you really understand this stuff, guys, it's amazing because you're going to be able to look at an equation and you're going to be able to visualize that this parabola is at the vertex 4, 6, and it's opening up and it's kind of narrow. Just by understanding transformations, you'll be able to answer multiple choice questions just by looking at the equation. Let's do one more. How about number 3 here? What's the first thing to try to state with regards to transformations? It's up on your notes. The reflection. So let's write, it gets reflected over x axis. Now, what does that really mean? That means that it used to open up, now it's going to open down. Okay. What's the next thing that we could say? And remember, the first 2 things come from the A value. Does it get reflected? And then does it get wider or narrower? What do we say?
Wider.
It gets wider. But how are we going to, the correct math words to use is going to be what? It gets vertically compressed. What does that mean? That means wider. By a factor, how does it get wider? By a factor of what? Of 1/2. Don't put the negative because the negative just tells you that it's going to open down. And we already stated that when we said that it got reflected over the x-axis, right? So don't put the negative right there. It just gets compressed by a factor of 1/2. It got wider by the factor of 1/2. And last but not least, we're going to describe our shifts. So this gets shifted 3 to the left and 4 up. So we will have a couple of these questions where you have to just look at an equation and say, from my parent graph, describe all the different transformations that it has to go through in order to get to this new t of x function, which is this. Okay, what do you guys think? Cool. All right, so I don't have the answers to all of these posted. I will hopefully get them posted on Edmodo for you later.